The Wilson family was one of the first to come to the U.S. They had 8 children. Assuming that the probability of a child being a girl is 0.5, find the probability that the Wilson family had at least 2 girls and at most 5 girls. All right, there's a number of ways we could approach this problem. One of them is to come up with all the different ways that they could have had 8 children with their different gender combinations. And with 8 trials, that can take quite a while. So we'd be better off using the binomial probability approach. We need our N, P, and Q. The N is that we have 8 children, that we're going to have 8 trials of different genders. So each time we have a child, we'll be looking what the gender is, so that's why that's a trial. And then assuming that the probability of a child of being a girl, if we're assuming a girl is a success, that's 0.5. And of course, 1 minus 0.5 is 0.5. So now we have the building blocks we need to use the probability distribution function. Okay, so let's begin by creating the probability distribution. We know that we can have up to 8 successes, all the way from no successes. We could have all boys, no girls, all the way up to having all girls. And the binomial distribution will use the success, the number of successes, comma, the trial, absolute reference, and the probability of success, absolute reference, and false for cumulative. We just want the exact probabilities first. And we'll go ahead and just do the exact ones because the probability of at least 2 would be the probability of 2 or 3 or all the way up to saying or 8. Okay. So what that means is that I want to add up the probability of having 2 or 3 or 4 or 5 or 6 or 7 or 8. Just copy and paste that in. Okay. Now the probability of at most 5 would be the sum of, well, what's at most 5? 5 is included in that, right? 5 at the most, and fewer. So all these. Okay.